Good day, everyone. My name is Wendy Morales. Today I will present the topic of automatic polarity identification in unstructured tests using machine learning. The author of this work are PhD Rafael Guzmán Cabrera and a servant, the engineer Wendy Morales Castro. Well, first I would like to start with the content that will be shown throughout the presentation, starting with the introduction, next with the definition of sentiment analysis, the proposed methodology, experiment performed, conclusion, and finally, future work. As a first point, we have the introduction to the I would like to mention as a first point the bond that digital communication system currently have in recent years, which has allowed millions of users to share their opinions on various topics, people, situation, products, or service with other users. These opinions or comments have been through the well-known social networks, which have become digital space where users publish and disseminate information spontaneously and voluntarily. Statistical data belonging to the International Telecommunication Union, they indicate that currently 53.6% of the people worldwide make use of social networks, which becomes an emerging sector in the context of big data. This information can be analyzed by a computational treatment, which is largely the responsibility of natural language processing. Two areas of the natural language processing are sentiment analysis and polarity classification, and text polarity classification, which are currently the most active processing since the early on 20s. The present work we will focus in the sentiment analysis. Now I present a definition about the sentiment analysis. The sentiment analysis is a task of classification of tests with the processing of natural language, as mentioned in the previous slides. It is defined as the computational study of opinions, feelings, and emotions expressed in text. Its main objective is to determine the attitude towards certain products, situation, people, or organization. One comment on this, I would like to comment some of the more relevant articles relate to the first of the them was written in 2012 by the author Liu Bi, called Sentiment Analysis and Opinion Mining, and the next written in 2013 by Anta A. by Anta A.F., Chirog, and others, called Sentiment Analysis and Topic Dictation of Spanish, a comparative study of NLP techniques. The following belongs in the year 2018, written by Oscar N. and Ivan S., called Sentiment Analysis on Twitter, a test mining approach to the Syrian refugee crisis. And finally, we have the 2020 written by Priego Sanchez, called a new lexical resource for the evaluation polarity in Spanish verbal phrases. These articles were selected because they show a broad overview of the topic and use tools similar to the present work. Now I will present the methodology proposed. We designed this diagram and we describe in the next slide. For the first step, we have the data sets. For the present work, we use the semi-eval corpus 2018. It's called Task 1 Affect in Tweets, which contains tweets in Spanish, of which 3,562 belong to tweets for training, and 618 are for the test. Now the next step is about the preprocess. The objective of this stage is to preprocess the test entered into the system, that is, its clean characters that don't add value to the system of the emotion or polarity. Some means that are removed are punctuation marks, special signs, double space, emojis, among others, as shown in the step 1. Subsequently, among others, as shown in the step 2, is about the conversation, the entire sentence to lowercase. In order to standardize the text as shown in the step 2. It is continued with the tokenization of the sentence, which consists of the separation of the sentence in individual elements, and has in step 3, where it separates the sentence according to the tokens that are required, and finally we end with the lemmatization showing in step 4. The next step in the diagram is the emotion identification. The emotion identification. This stage is responsibility for identify the predominant emotion in the prep test processed that has been obtained in the previous stage. The identification is done by means of the test classification algorithm based on the decision tree algorithm, which is created from a collection of previously classified training data. It is the semi-eval corpus 2018 called Task 1 Affect Tweets, mentioned in the previous slide. The next step is polarity identification. The objective of this stage is to obtain a classification, positive, negative, or neutral, of the test already classified the stage of identification of emotions. The identification is made from the extraction of the post tags of the previous generate tokens. Subsequently, the slogans of the post labels that are declared in the lexicon for the Spanish language are analyzed, and in other words, not all slogans are analyzed. Only those found in the ML Senticon lexicon. Now, I present the experimental results that we apply in the to evaluate the methodology. 2 experiments were proposed. Each of the experiments that were performed were supported by the naive Bayes classification algorithm. The first experiment consists of relying on the analysis of motion, and it's generate two documents, two files, and creating a test class to extract the phrases from the corpus Semeval 2018. The file is file corpus text, and phrase result contains total of 755 tweets between a length between 100 and 240 characters. The rank was taken into account because tweets with lengths between 140 and 280 characters didn't exceed 133 records out of a total of 2,854 contained in the file for testing. Only the 755 the phrase file were entered. The text input file of the user interface, waiting for the results. And the second experiment used Weka, and each user the interface implement a classifier based of naive Bayes algorithm, and the same training corpus mentioned in the previous slide. The criterion of innovation do use the same corpus for training and test, with different percentage of training and test. In the first instance, with 66% of the training and 33% for the test. In the second instance, in 80% of the training and 20% for the test. And the third instance, with 90% of the training and 10% for the test. Now, the results of this experiment, we can show in the table 1 and the table 2 the result for the first experiment. The table 2 shows the motion and polarity identification results of 700 sentence, the test 1, and the table 2 shows the motion shares in the input file. Now the next tables show us the results, the ranking results, percent split for the experiment 2. The table 3, show the results for the experiment for 66%, the table 4 for the 80%, and the table 5 for the 90%. And the table 6, 7, and 8 will show us the table 6 is respect to the classification model of 36%. The training were made of 155 input phrases in the system, and the model was generated with 66% of the instance. The ranking results are in the table 6. Later in the table 7, we show us the percentage split option of the 80% for training and 20% for the testing was selected. The ranking results are shown in the table 7. And finally, in the table 9, the percentage split option of the 90% for training and 10% for the testing was selected, and the ranking results are shown in the table 8. The table 9 contains between the number of emotion and polarity is identified by the proposed methodology. The result corresponds to this one, the classification of phrases from the corpus of evidence. From the table 9, it's observed that for each emotion there is a majority tendency to the positive polarity of the phrase. However, for the emotion of joy and love, this trend exceeds 50% of the total polarities detected. The emotion with the lowest percentage of positive polarity are anger and sadness. For the test development in WECA with naive Bayes algorithm, the overall result can be seen in the table 10. And finally, the table 11 contains the result of the test 3 classification of phrases from the training corpus. Now, I will present the conclusion about the presentation. In this article, we management to design and implement a system that provides a category or emotional tone and polarity of a phrase or text with consist authorship between the two. That is, most tests report that they're in a different relationship between phrases. For example, with the emotion of joy and positive polarity, Haswell has a lower relationship of positive polarity with phrases or negative emotion. Although the results don't provide an accuracy, since it depends entirely on the intention of the author, the correct use of the word in Spanish, the use of blasphemies or sarcasms, abbreviation idioms, the classification algorithms, the monitoring methods, the volume of training and test data, the category made in provides meta information based on the real cases and training with data development by exploring the field. This categorization can be used by systems that have large volumes of information for feedbacks or self-learning, systems that take into account many linguistic variants for more accurate classification. For the future work, this article can be expanded to use some other classification algorithm and expand the categories of emotion, use some other lexicon or other text classification models to obtain greater accuracy in the categorization. In this slide, I present the reference used in the present work. And finally, thank you for your attention. My email all are in the present slide. In the same case is the email of the PhD Rafael Guzmán Cabrera. Thank you for your attention.